The views expressed on Science for the People are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
This week on Science for the People, we're talking about how climate change is altering the face of the planet and affecting the lives of the people who live here. Welcome to Science for the People. I'm Desiree Schell. Later in the hour, we'll speak to sociology researcher Stephen Castles. We'll discuss the factors driving human migration and how they could be affected by the shifting climate. But first, I'm joined by Christoper White. Chris is the author of several books, including Skipjack, the story of America's last sailing oysterman, and he's written for National Geographic, Exploration, and other publications. He lives in Santa Fe, New Mexico, and he's here today to talk about his new book, The Melting World, A Journey Across America's Vanishing Glaciers. Good to have you here, Chris.
Thank you, Desiree.
Now, your book takes place in Glacier National Park, so maybe let's set the scene here. Tell us a bit about the park.
Well, the park is one of the most gorgeous sites in North America. It's always been known for its glaciers, and before the park was created in 1911, there were 150 glaciers in the park, in the area that became the park. And over the years since then, the glaciers have just been vanishing. So it's sort of ironic that the name remains Glacier National Park when today there are only 25 left, and it's expected that those will be gone in another decade.
Now, why set the book there specifically?
Well, I was interested in exploring the concept of what it means that we're losing our alpine glaciers. A lot had been written about Antarctica and Greenland and the polar ice caps and those lowland glaciers, but not much had been done about alpine glaciers. And I was very interested in them originally because mountaineering has always been a great avocation of mine. And so I wanted to find out what had happened to them. And I knew that around the world, 50% of humanity's water that's used for irrigation and drinking and hydroelectric power comes from alpine glaciers. And those are disappearing all over the world. But it came to my attention that Glacier National Park was a place where a microcosm of that loss was happening, because what was happening in Glacier National Park would eventually happen in the Alps and the Himalayas and the Andes and elsewhere. And it was just beginning here. So I set out to document not only the glaciers that were disappearing, these last 25 glaciers, but also what were the downstream effects? What does it mean that those glaciers are going to be gone? What happens to the aquatic resources? What happens to the ecosystems? And that intrigued me.
So why is it that global environmental problems often appear in alpine and polar regions first?
One of the reasons is that the temperature is increasing most around the planet in Arctic regions, polar regions, and in alpine areas. And the reasons for that are very complex, but I can tell you the reason for it happening in Glacier National Park and the Cascades and the Rockies. The reason is that they're positioned in such a way that because of their altitude, first of all, they have a greater temperature increase because they're more elevated and closer to the sun. And then also because of their northern distribution, they're more likely to have the jet stream come across them and bring warm air from the Pacific. So in Glacier National Park, for example, the temperature has increased there 1.8 times, almost 2 times the amount of the global average temperature increase because of global warming.
I think most of us know that melting glaciers lead to rising sea levels, but that is not the only reason that they are important, correct?
That's true. One of the key things about alpine glaciers, even more so than other glaciers, lowland glaciers, is that they're an indicator that climate change is underway. And also, they have all sorts of impacts to the mountain ecosystem because everything is so finely tuned together and so finely intermeshed in the mountain environment.
Well, and you wrote that 20 years ago we predicted very, very few of today's outcomes of melting glaciers. So what exactly was surprising?
I think that the most surprising thing in my research was that glaciers are so important not just to the immediate environment in the mountains, but also everything downstream. And the cascading effect of downstream impacts is just so remarkable. All sorts of things that you would never expect would be impacted fall like dominoes from aquatic resources like in Glacier National Park, the glacier stonefly and the cutthroat trout, to mountain goats and bighorn sheep that are losing their pastures in alpine tundra because of the timberline climbing up the hill.
One of the things that actually surprised me is that we didn't predict disruptions to ocean currents.
Well, some people say, well, what's the big deal about alpine glaciers because they're not really causing the seas to rise. But the alpine glaciers are really only contributing about 1% to the sea level rise that's occurring around the world. And polar glaciers and Greenland and Antarctica are really contributing the most to sea level rise. But when you have the water, the fresh water that's melting from the polar ice caps and to a much lesser extent from alpine glaciers, that water enters the oceans and causes a change in currents. And one effect is starting to show is that as the Gulf Stream becomes warmer, and also that there's more fresh water riding into the Gulf Stream, that Europe and England will become milder climates.
So, your book follows Dan Faegre and his work at the park over a period of 5 years, starting in 2008. So what's his role there?
Dan Faegre is the guru of glaciers in Glacier National Park. He's an ecologist by training, but just simply because he's been there for 20 years monitoring the glaciers in Glacier National Park, he's become a glacier expert and a glacier scientist as well. And what he does every summer with a team of maybe 4 or 5 graduate students and technical advisors that he has on his payroll, they set off into the mountains and monitor what's happening with the glaciers, how fast they're disappearing. And he does that with various different techniques, which range from using GPS equipment to see exactly how the shrinkage is happening. They also do a technique called mass balance assessment, and they even use kayaks on the lakes that are at the base of these glaciers to measure the actual extent of the glaciers at the lower end.
So let's talk about that because I'm interested in a lot of the techniques. So, how does one survey glaciers? Like, how can you tell how fast a glacier is moving?
Well, you have to have a baseline, some sort of a baseline. So there's a couple of ways to do that. The simplest way is to look for archival photographs. And Dan has done this. He's gone back into the National Park Service archives back to the turn of the 20th century and uncovered photographs of various glaciers from various vantage points. And then his team is set out to repeat those photographs by climbing to the exact point where the previous photographer was. And that's a trick to be able to do that. But when they find the exact point that the previous photographer took the photograph maybe 50 years ago, 60 years ago, 90 years ago, they then take that same photograph again and compare the two of them. And they can see if both photographs were taken, let's say in August, one photograph was taken in 1890 and the second photograph was taken in 1998, which is the exact dates for one pair of photographs from Grinnell Glacier. They can compare those and see exactly how much has disappeared. But that's the simplest, most primitive way to monitor glaciers. The most sophisticated way is to do a thing called mass balance. And that is actually the standard that's used for monitoring glaciers all around the world. And the data from gathered for mass balance techniques is put into a database that everyone shares around the world. The way that works is you go to a glacier right at the point when winter snow has finished falling, which is typically in, let's say, May. And you measure by using a very long probe, like a 30-foot probe, you measure how much snow has fallen on the glacier. And you do this in several places around the glacier and then average those. So you get an average of how much snow has fallen for a given winter season on a given glacier. And then you go back at the end of the summer after all the melting has taken place, let's say around the day before Labor Day or after, and you measure how much of the snow has melted, and then you compare those two things. You take the measurement from May and of the actual snow that's accumulated, and you subtract from that the snow that is melted. And if the balance is positive, it means that the glacier is growing. But if the balance is negative, it means that the glacier is wasting away.
Now, you make that sound very calm, but I read your book, and it is terrifically more terrifying than that.
Well, oh, you mean being on the glaciers themselves?
Indeed,
Oh, yeah.
just to get in the position to make these kind of measurements.
Well, that's true. That's absolutely true because when in May, I didn't go up with the scientists in May when they measure the snowfall for the winter season. But when they do that, they have to ski maybe 10 miles all uphill to the glaciers because the snow is so steep that they can't snowshoe and they can't walk up to the glaciers at that point. I've been with them several times, many times over the last 4 or 5 years in August, when still it can be really treacherous to go on a glacier because glaciers, as we all know, are laced with crevasses and other pitfalls. So you have to be very careful. Typically, the team ropes up and employs ice axes and crampons on their feet to navigate the glacier to get to those particular places where they're doing those measurements. It's very exciting.
I'll revert to terrifying myself, but thank you. I'm glad someone's doing it. So, now, how accurate are these kinds of methods at this point?
Well, they're pretty accurate obviously for mass balance, you need a series of years because you need a baseline, as I was saying before. So, the first time they started to do mass balance was in Glacier National Park was about 10 years ago. So that set the baseline of what they compare the future years to. And then the they add snow or they lose snow over the series of years that ensue. And as far as accuracy goes, I don't know what the exact standard deviation of the work is, but they do statistical comparisons from one glacier to another and get a sense that, well, if this glacier is losing mass balance, well, then this other one is too.
This is important to the health of a glacier that you make these measurements, but it's also important when we're trying to understand climate change.
Yeah, that's true. And alpine glaciers are really remarkable. I mean, it's another thing that I discovered that I didn't know when I first set out on this project. Alpine glaciers are very finely wired to the climate, and they're perfect indicators of climate change, more than just about anything that you can think of. When we talk about climate impacts, such as an increase in storms, like more hurricanes occurring on the east coast of the U.S., or we think of droughts occurring in Africa or floods occurring in Asia, and these storms becoming more intense. Even when one of those storms occurs, you can't point to that particular storm and say, aha, this is climate change. You can look at a pattern over 5, 10, 20 years and say, oh, we have a lot more storms. That must be climate change, and that makes sense. But for a particular storm, you can't really prove that the cause was directly due to climate change. Well, it's very different from glaciers. For glaciers, as we all know, what melts ice? Heat melts ice. And the reason that the glaciers are disappearing is because the temperatures have elevated. And what makes a glacier is snowfall occurring in the wintertime, and what we lose from glaciers is because of heat in the summertime, for the most part. And we're getting less snow in the winter because of climate change, and we're getting more heat in the summer and throughout the year because of climate change. And the glaciers are responding perfectly to that scenario.
This is Science for the People, and I'm talking to Christoper White about his new book, The Melting World, A Journey Across America's Vanishing Glaciers. So there's a number of also indirect methods that you look at to surmise the health of a glacier. The trees and the plants in the park are monitored.
That's true. Everywhere you look in a mountain environment, in an alpine ecosystem, you see the effects of climate change. And some of those are very good indicators of climate change, very closely track climate change, and others not as well. One that doesn't track it as well is the tree line changes that are occurring in Glacier National Park. What's happened is because of there's less snowfall in the wintertime and less snowpack, the trees are gradually moving uphill, and the timberline is now a higher elevation than it was 10, 20, 50, 100 years ago. Now, you don't get a perfect correlation uh, in any given spot. If you look at an area like one mountainside or the north side of a certain mountain, you don't get a perfect correlation that says, okay, well, this change in tree line is because of climate change. But in Glacier National Park, you look at mile after mile after mile of tree line change and climbing uphill, and you can say, well, this is because of global warming. And right now, when a lot of the glaciers that I visited during the project showed trees trees growing where the glaciers used to be, because the glaciers are receding in the rubble that's downstream from the glaciers. There are trees growing in those places that never grew before.
Well, that was one of the things that you mentioned in the book. The projection is that more diversity in plants will be caused by climate change, and that doesn't sound bad, does it?
It doesn't on a larger scale, but when you think about an ecosystem, each ecosystem and habitat is unique, and the plants and trees that grow in a particular ecosystem are suited for that particular environment. So as temperatures climb, you could have more plants as far as diversity goes on an alpine summit, for example, because plants are moving uphill and they end up crowding themselves and crowding with other plants that were already on the mountaintop. But that also means that eventually the alpine plants are going to be crowded out and will no longer be there. So you won't have a true alpine environment like you used to have.
Okay, so there's another. I have this immense list of indirect methods, and I want to try and get to as many of them as I can. It looks like Dan became a bit of an avalanche expert as well.
Yeah, yeah, he's really remarkable. Dan Faegre is a jack of all trades, and he dabbles in just about everything in the park that has to do with climate change and its impacts.
So, what can we learn from avalanches then?
Okay, well, avalanches are remarkable because this is another thing that I had no idea about before I got into this project, which was really thrilling to discover. Avalanches we think of avalanches as being dangerous, as being destructive, as being a nuisance and a problem. And in actual fact, avalanches are very important to the mountain ecosystem, just like fires are. We used to think that fires were just simply destructive, but we know now that fires renew the forest and allow plants to renew themselves and grow back. And we end up with a mosaic in a forest on a mountainside rather than just sort of a monotypic tree stand. We get many plants and many trees, whereas if there was no fire, you would just simply have one stand. Well, the same is true with avalanches. Avalanches, which crash down a mountainside, wipe out trees and plants and rub the earth down to rubble. And yet, a couple years later, you start to see wildflowers in that avalanche track. You see willows and aspen growing back. And eventually you see larger trees that could become larger dominant species coming back onto that avalanche track. And that's really remarkable. So, what does that mean? I mean, if avalanches are good for the mountain ecosystem, what does it mean in the face of climate change? With climate change, what Dan Faegre is expecting is that for the short term, we will have a lot more avalanches. And the reason he says that is because now we have rainfall in the wintertime. It used to be that snow was the only thing we ever saw in the wintertime. Now we're seeing rain events in Glacier National Park in January and February. And that rain triggers avalanches because the snow becomes wet and less stable and crashes down the mountainside. Avalanches in the short term might increase, but over the long term, Dan Faegre is expecting that with less snowfall, there will be less snowpack at higher elevations, so we won't see as many avalanches. If we don't see as many avalanches, let's say 20, 30, 50 years from now, we won't have that diversity of the landscape. We won't have that heterogeneity that we depend on to have a very diverse alpine ecosystem.
Well, speaking of the ecosystem, the wildlife in the park can tell us a lot. You explained it very well when you wrote about the cutthroat trout and the cascade effect.
Glaciers are at the headwaters of watersheds. And below those watersheds are creeks, streams, rivers, all flowing downhill. And in those rivers are a very important species, the cutthroat trout in Montana. And that trout is very much in danger right now. The reason that it's in danger is that the rainbow trout, which is an exotic species that comes from the Pacific coast, which was introduced into Montana for anglers because it's a very good angling fish, are now interbreeding with the cutthroat trout, and the hybrids are less fecund and or less able to reproduce and are not the same as the original species.
So is this actually a problem? Because it seems like there's some discussion as to whether hybrids are actually bad or if we shouldn't be protecting them as well.
Well, every species is important, I would say, around the world, and we should try to assure its authenticity and its originality as much as we possibly can. The cutthroat trout was perfectly suited to Glacier National Park and Montana and British Columbia for centuries and millennia, and lived there in perfect tune with the environment. And now it's losing its genetic originality, which is really a shame. And you might have a hybrid, but it's not the original species.
Well, we don't have that problem with the pine beetles. They're just overall a problem, and that is in my neck of the woods. So maybe can you just briefly cover what's going on there?
I live in New Mexico, and just north of here, it's really begun. The problem with the pine beetles begins up there in Colorado, and from Colorado through Wyoming and Montana to British Columbia and Alberta, the pine beetle is wreaking havoc on lodgepole pines mostly, and other pine trees as well. And what's happening is that the pine bark beetle that used to just simply invade trees in Colorado and a little north of there is moving north. And the reason why it's moving north is because winters are less intense because of global warming. The reason is that pine bark beetles used to have their population kept in check because they couldn't survive the winter when winters were very cold, going down to 50 below zero or so. And now the winters are so mild, with temperatures only dropping just below zero to 20 degrees below zero, the pine beetles can survive and don't die off. So they're able to complete now maybe two of their cycles, of their reproductive cycles in a given year, whereas it used to be that they only had one reproductive cycle during a year, which means that they're just explosive. They're just moving like gang fire farther north. And I think that the worst situation is in British Columbia, but it's also affecting areas in Montana as well, and they're expecting it to come very fiercely in Montana in the next few years.
Okay, so you're monitoring the health of the glaciers and the health of the park in many ways, and then you get all of this data. And so, what does this mean when you look at all of this together? What does it mean?
Well, it means that
Nothing good, I assume.
right, right, right. I mean, we're definitely in trouble, and the impacts that we're seeing in Glacier National Park, as I said earlier, Glacier National Park is a microcosm of mountain ranges all around the world, and what's happening there is happening um, first. So what we're seeing all these impacts ranging from the glaciers disappearing to cutthroat trout becoming hybridized, to the tree line climbing up the slopes, to mountain goats running out of alpine tundra to eat. All those effects of climate change are we're going to see in the Alps and in the Andes and in the Himalayas in the years to come.
So, let's look at it from another perspective. How old are the glaciers?
The glaciers in Montana are probably about 7,000 years old.
And this isn't the first time that there's been a warming period, I assume.
No, that's true. There have been warming periods over the millennia. There was, of course, before the Pleistocene happened 1 to 2 million years ago, there was a huge warming period. And since the Pleistocene ice sheets that covered all of the northern part of North America, there have been um, many interglacial periods. But what's different about this one is that it's happening so fast. They Before, when there was an interglacial period and glaciers started to disappear, it happened very slowly over hundreds of years, over thousands of years. This is all happening in just the blink of an eye. And we're seeing, I mean, to see at Glacier National Park 50 glaciers that they had in about 1920, 1930, for all of those to be gone in another 10 years from now is just incredibly fast. And that's the scariest thing, the speed that's happening. The impacts that are happening because of global warming are happening at such a swift speed that we're really in trouble because of that.
Well, how often do glaciers melt away altogether?
Well, the glaciers in Montana would have reached their peak, their previous peak at about 18,000 years ago, right before the Pleistocene started to melt. And then they had another peak that came maybe 9 or 8,000 years ago or so, and then they reformed 7,000 years. So in the Pleistocene, it was really a matter of 1,000 years or a couple thousand years or 5,000 years or 10,000 years that there were interglacials.
What I want to know is if we were capable of getting it together, they could come back.
The problem, wouldn't that be great if that was true, that they would come
I'm
back
thinking I've
in any
solved all our problems right
right,
there.
that's great. That would be wonderful that was easy. But the problem is that the carbon dioxide loading in the atmosphere is happening at such a rate and is so persistent. By persistent, I mean that when carbon is released into the atmosphere because of burning of fossil fuels, that carbon stays there for at least 120 years. So that means that all the carbon dioxide from smokestacks and factories and cars and agriculture that we're putting into the air in 2013 is going to be here for 120 years. So every time we load more, it's 120 years more of carbon. So it's a long time coming.
So what you're saying is no, Desiree, your idea is dumb.
Well, I wouldn't say it's dumb. It's really it's wonderfully optimistic. But the only way that the glaciers can come back is if we cut back drastically on carbon loading. I mean, and by drastically, I mean I think the forecasters say that we need to cut carbon loading in half to have a safe environment.
And that's exactly what we're going to talk about next. You're listening to Science for the People, and we'll be back with Christoper White and his book, The Melting World, after this.
Science for the People is a weekly radio show exploring everyday life from a scientific perspective. To find out where Science for the People airs near you, or to listen to past episodes, check out our website at scienceforthepeople.ca. You'll also find links to connect with us on Facebook, Twitter, and Google+, or to subscribe to the podcast in iTunes. And now, back to the show.
Welcome back to Science for the People. I'm Desiree Schell, and my guest today is Christoper White. Chris is the author of several books, including The Melting World, A Journey Across America's Vanishing Glaciers. Now, when your book began, Bush was actually the president, and so there were some things that Dan wasn't allowed to discuss with you, correct?
That's absolutely true. The U.S. Geological Survey, for which Dan is the chief scientist in Glacier National Park, is the science arm of the Department of Interior. The National Park Service that runs the park actually is its sister agency. And back in the Bush years and in 2008 when I began the project, all the scientists in the U.S. Geological Survey were prevented from speaking about policy in regard to climate change. They could talk about, and he in particular could speak about the science and the impacts and the causes of global change, but he couldn't speak about policy.
And Obama was actually elected partway through. So was it just me, or did Dan seem to be more able to speak to what we actually need to do in terms of policy? Or maybe that was just desperation talking. I'm not sure.
Yeah, I think that he was a little looser, yeah, in the Obama administration, yeah.
Well, regardless, he thinks that we've passed the tipping point at Glacier Park, doesn't he?
Yes, and partly that's because of that persistence I was talking about of carbon loaded in the atmosphere. The glaciers that are disappearing right now, the last 25 that exist, he has claimed that there's no stopping them from becoming extinct. Because if we try to make changes in the next 10, 15 years, it wouldn't be quick enough. It's just too little too late.
So what's his projection then?
Originally, when I started the project, he had made a prediction in 2003 that the glaciers would survive for 30 years. So that meant that the glaciers would survive till approximately 2033. And then during the course of the last 10 years, he's seen the mass balance rates increase. He's seen the melting increase. And so he's estimated that the glaciers will disappear in about a decade or so.
See, I'm wondering if people really understand that. That is well within our own lifetimes.
It is. I mean, it's really shocking. I mean, that happens that quickly. You know, you think of like ice ages and glaciers and how slow they move and a glacial movement. And we tend to think that glaciers are long lasting and hardy and durable. And yet these are just evaporating.
So what would that mean for the park then?
Well, it's a good question. Can you still call it Glacier National Park
Exactly.
when there are no glaciers in it? The National Park Service personnel have taken sort of a PR stance on that issue, and what they're saying to anyone that asks is that, well, the park has beautiful mountain ranges and cliffs and huge rock escarpments that were carved by the Pleistocene ice sheet. and that makes it Glacier National Park, even if there aren't any current glaciers there.
That was absolutely created by PR people.
Well, that's what they're saying.
Well, Dan, luckily, is an optimist. He's holding out hope for other glaciers.
He is, and I think that's what the real gift that he has made to scientific research in doing all these studies on the impacts of glaciers in Glacier National Park, which is on a fast track to oblivion. He's really paving the way for our understanding about what's happening elsewhere. If we immediately begin to cut back on carbon loading into the atmosphere, the Himalayas and the Andes can probably be saved. The next mountain range that's probably in trouble if we don't do anything in the next 10 or 20 years is the European Alps. The Alps currently have about 1/3 the amount of ice that they had in 1850.
And are they being monitored like
Yeah,
Glacier Park?
they are being monitored very heavily.
And the projections are?
Well, the projections are that there's been mathematical modeling done on the European Alps, and those models, which came out about a year or two ago by the University of Zurich in Switzerland, say that if there's a 3 degree Celsius increase in temperatures over Europe over the next century, that's 5 degrees Fahrenheit, that there'll be an 80% loss of the remaining glaciers that are in the European Alps. And if there's a 5 degrees Celsius increase, that's 9 degrees Fahrenheit, by 2100, there'll be nothing left.
Okay, well, just to add some more distressing news in, we should probably mention an unfortunate piece of recent news. The carbon dioxide level in our atmosphere just passed an important benchmark, didn't it?
It did. It did. The way the carbon loading is measured is by how many parts per million carbon dioxide is in the atmosphere. And for the last 3 million years, and that means going back before or to or before the years of early man, the carbon dioxide level has been between 180 parts per million and 280 parts per million. It's changed over time. It's been lower, like around 180 parts per million during ice ages, and 280 parts per million during interglacial periods, warm interglacial periods. But now it just crossed in May, it crossed the 400 parts per million threshold. So what does that mean? Well, in 1900, the level was about 280 or 285, and now it's 400, only 113 years later. That's an increase of, I can't do the arithmetic off the top of my head, but I think it's about 40% increase. If you keep making those percentage increases over time, the loading of carbon dioxide is going to be 450 in perhaps 20 years, because it's increasing right now at 2.5 parts per million a year with current loading of carbon dioxide. So it has not been at 400 parts per million in 3 million years since man has been on the planet, and now we've just crossed that threshold because of our burning of fossil fuels.
Okay, so you wrote this book where Dan is your main character, and he is relentlessly optimistic. But you sort of had your own perspective on that. Are you as optimistic as Dan, or what do you think about all this after 5 years of being with this team and monitoring the glaciers?
Well, I really fell in love with Glacier National Park. It's just so beautiful. I'd hiked there in 1976 when I was just 20 years old, and going back and spending the last 4 or 5 summers there has been a real treat for me to see that beautiful landscape. But of course, it's been bittersweet because I've also witnessed the impacts of global warming that are happening and the glaciers disappearing. I mean, when I started the project in 2008, there were 27 glaciers in the park, and 2 disappeared while I was working. In 5 years, 2 disappeared, which is just shocking to me. And so you can't help but be a little depressed going through that. But I do share Dan's enthusiasm for the chances that by changing our ways, we can save glaciers elsewhere in the world, but they're lost here.
Chris, thanks very much for being here.
You're welcome.
You can find a link to Christoper White and The Melting World on our website at scienceforthepeople.ca. And we'll be back to discuss human migration with sociologist Stephen Castles right after this.
On the next episode of Science for the People, we're looking back in history and to the modern day to discuss women who defend and advance science and learning. Desiree Schell speaks to author Faith Justice about her book Hypatia, Her Life and Times, which examines the literary myths and primary sources on the life of the famous philosopher. And she's joined by Professor Zara Hazari to discuss her work on gender issues in science education. That's next week on Science for the People, on your local radio station, or online at scienceforthepeople.ca.
Welcome back to Science for the People. I'm Desiree Schell, and my guest is Stephen Castles, research professor of sociology at the University of Sydney and research associate of the International Migration Institute at the University of Oxford. His current research project, Social Transformation and International Migration in the 21st Century, is concerned with the way that global forces interact with local factors to shape human mobility. Thanks for being here, Stephen.
It's a pleasure. Thank you.
So how does one study migration exactly?
Well, migration cuts across all areas of people's existence. So we need an interdisciplinary approach using sociology, political economy, economics, law, anthropology, psychology, pretty well all the social sciences. And what we're trying to do here in our project is to start with a national level study of how global forces lead to migration and how migration changes societies. We're looking at Turkey, South Korea, Australia, and Mexico. But we're then doing a local study. We're choosing one neighborhood or one village that has been substantially affected by migration and really talking to a lot of people. And we're talking both to migrants and non-migrants because, of course, the non-migrants are affected too.
So what kind of tools do you use then? How do you track it?
We work at multiple levels. I mean, we've done a global literature review. I'm working with 5 doctoral students on this. And then we go to the countries concerned. And fortunately, I have students who have the right language skills from those countries. And we talk to high-level officials, members of parliament, heads of government departments, heads of NGOs, people at that sort of level. Then we go to a local level and talk to what we call local key informants, which means mayors, perhaps police commanders, priests, imams in Muslim countries. And then we talk to individuals. We do interviews with, as I said, migrants and non-migrants, selected quite randomly. And we do in-depth interviews with open-ended questions because we don't want to prescribe what people can say. So we want to listen to what they say. And that means, of course, that we get a lot of data which is not really very organized as it would be if you did a formal survey. So then we have to do a qualitative analysis, and we're using a data package that helps us with that.
So what would the information on migration generally be used for?
Well, it's used for a whole lot of things. One is, of course, government policy making. It's also used for criticizing government policy making. Governments tend to be very keen on numbers and they like economic analysis, and they often don't look at what it means for the people on the ground. We're much more interested in what it means for both migrants and non-migrants, and the way neighborhoods get changed, the way migrants make places, you could say, and for how they interact with existing populations. And that's why we're looking at very different countries. I mean, think of Korea with its idea of ethnic homogeneity or cultural a monocultural society, and it's really been changed a great deal by immigration, and people are having to come to terms with that and think about what multiculturalism could mean for Korea. And then by contrast, Australia, like Canada, of course, is a society built on migration where we have very much the idea of having diversity and that people should have cultural rights and can still be good citizens, good Australians, and very much contribute to our society. So there are very different views on this.
Well, what kind of migration patterns are you seeing then in your research?
Well, obviously, economically driven migration is very important, but forced migration is significant for some countries as well. Particularly, I mean, it's certainly significant for Australia. We're looking at one emigration country, Mexico, and Mexico is very interesting because you can really see how neoliberal developments have affected Mexican patterns of life and work. So, for instance, before 1994, there was, of course, steady migration to the United States, but it wasn't so large. After the North American Free Trade Area, NAFTA, came into being in 1994, there was a radical change in patterns because Mexican agriculture was very dramatically affected. A lot of forms of agriculture, bean farming, maize farming, which were traditional activities, became unviable because of the competition of the highly mechanized and subsidized US agriculture. So there was a huge increase in emigration because people just couldn't work in Mexico anymore. That was fine until the early 2000s, and then came the crackdown, especially with the recession after 2008, there came a crackdown on migration from the US side. But the other thing that happened was that by making it much harder to cross the border, the United States created a business opportunity for what are called coyotes. In other words, people smugglers who used to take people across the border for about $1,000 because it was too dangerous by then to do it on your own. In the meantime, that small business opportunity has been taken over by large business in the form of the drug cartels, who extort vast amounts of money from people and torture or kill them if they can't pay. So it's become too dangerous to cross the frontier. And that leaves a whole lot of young people with no perspective in life at all. The Mexicans call them ninis, and that stands for ni escuela ni trabajo, which means neither school nor work. These are young people who just can't get an education and can't get a job. And they've got two options. One is a life of poverty, and the other is to become a soldier for the drug gang and live very well for a few years till they get killed themselves. So it's a very dismal perspective, and you can just see the interaction there of neoliberal globalization in the form of NAFTA and the way migratory patterns have developed.
Well, now, how does climate play a role then?
It is almost impossible to find an example of international migration where climate is the main factor. It's often one factor among others. The main reason for economic, or the main reasons for economic migration, for international migration, are economic change, change in the country of origin, in the sense that as they get penetrated by capital from multinational corporations, that increases the efficiency of agriculture and usually reduces the number of jobs available so that people actually become unemployed, even though it's beneficial, of course, that food production grows. And so they have very little option but to move from the country to the cities and or to move internationally. So, the economic forces are dominant. In some places, it's political forces where you get civil wars or a high level of oppression of certain ethnic groups. I mean, Syria is an obvious example, or Iraq or Afghanistan, where military force has made life unsustainable for many people, so they're forced to move as refugees and asylum seekers. But environmental forces play a part, but not, I would say, the major part. And one of the really interesting things that emerges from research on this topic is that people these days are more likely to move into areas of environmental stress than out of them, because the biggest migratory movements in the world at the moment are into big cities. And many of those cities, if you look at the cities on the Chinese seaboard, for instance, or the Mekong Delta, many of those cities are extremely vulnerable to flooding and other environmental events. So people actually move into areas of environmental stress, not out of them.
Well, the United Nations estimates that in 2008, 20 million people were displaced by climate change. So where are they getting that
I
number?
think you're wrong about that. The United Nations did put that on their website and then took it down again. But it was
Oh,
pointed out that was based on completely wrong analysis. And I can tell you where it comes from. Um, I used to be at Oxford University, and one of my uh, a fellow at my college, Green College, Oxford, Norman Myers, came out some years ago with vastly inflated estimates on the effects of climate change on migration, which have been debunked again and again, but still are very popular with the media because the media loves sensation. And unfortunately, the UN has picked that up too. The best scientific analysis of this topic is actually one done by the British government chief scientist, which was published about 2 or 3 years ago, called the Foresight Report. And they commissioned about 100 papers by scholars working on these themes all around the world. And they come to the conclusion that there is actually no evidence at all that international migration has been caused by climate change, except in a few very restricted cases, namely the very small Pacific islands like Kiribati and Tuvalu. We're talking there are a few thousand people who've been displaced, not millions. And the other case where you could probably make the argument is Bangladesh, where flooding has been one of the factors leading to migration to India, labor migration to India. But it's certainly not the only factor. And what this report shows is that where environment plays a large part, for instance, drought, flooding, um, changes in rainfall, this sort of thing, it nearly always leads to internal migration, not international migration. And often that migration is temporary in character, or it can be partial in the sense that a family that is having problems in agriculture might send one of their members to be a rickshaw puller or a driver or something like that in a city. But it's hardly ever whole families moving. So environmental displacement is actually in itself a very small phenomenon. Now, the interesting conclusion of that British government report, and I should stress I hardly ever find government reports good, but this one really is very good. The conclusion is that even though there's very little evidence that it's happened already, um, we shouldn't be complacent about it because we know global warming is taking place and climates are changing. So what we need to do is adopt a whole range of measures to increase the resilience of populations who might be exposed to climate change and to make it easier for them to adapt when things change. So we need a policy that looks to the future, but we shouldn't adopt these really alarmist views that millions and millions of people are swarming into other countries. It's just not happening.
this is fascinating to me because the article that I got that information from is I think less than a week old. So this is definitely something that's being promoted and re-promoted by the media. So what do you think?
Unfortunately, it's being picked up a lot by the media, and there have been some incredible accounts. I mean, the worst one was put out by a British aid organization called Christian Aid, which published a paper about 6 or 7 years ago called The Human Tide, a really sensationalist title. And they claimed that up to 1 billion people would be displaced in the next 20 years or so. And when one looked at the evidence, it was so thin. It was just, it was really infuriating. But what infuriated me about it was that they'd come and consulted us at Oxford University, and had actually put my name there as someone they'd consulted, even though they'd said exactly the opposite to what I'd said.
Well, I feel like you're straightening it out today.
Well, I really recommend anyone who wants a good account to download this British government report, which you can get free of charge on the internet, and really is the state of the art in this area. But I think what's really important about that report is that they say, even though it hasn't happened yet, we should be looking at the possibility and taking measures. And it should be an important part of development aid to less developed countries, that we look at ways of increasing resilience to climate events and to long-term changes in the climate.
So then what would those measures look like?
There are a whole range of things. I think the first thing is to analyze what sort of climate change is taking place, because there have been patterns of seasonal migration relating to environmental factors for many generations, like, for instance, the movement of farmers in West Africa according to the seasons. Even in Europe, we had this phenomenon of transhumance, where shepherds used to move up into the mountains at certain seasons and move down again. So these things have always existed. So those are seasonal patterns. Then there are patterns of societies that become affected by or vulnerable, let's say, to climate events. And that can often be due to population growth, so that people are settling and are forced to settle in areas that would have been seen as quite marginal in the past. For instance, when we had the Asian tsunami of, I think it was 2004, some of the areas that were swamped were areas that hadn't been settled 20 or 30 years ago and now had quite substantial populations, which were living in areas which were really not suitable, living on floodplains, living very close to low-lying coastlines. And then we have the phenomenon of human action that increases vulnerability. And there an example was the floods in Myanmar a few years ago, where I think it was a hurricane whipped up the sea and a lot of coastal land was flooded. Well, one reason for that was that people had cut down the mangrove forests, which had protected the coastline, in order to build shrimp farms. So, removing natural factors like mangrove swamps or building on wetlands obviously increases vulnerability. So we should be looking at that sort of thing and planning settlement patterns and economic patterns to reduce vulnerability. Then there's the issue of what's called resilience in this field. In other words, that there are certain areas where flooding, does take place periodically, like in Bangladesh. And you can increase resilience by building shelters, having escape plans, having plans for people to move temporarily and then come back to their farmland, because people don't really want to abandon their land. There's a big range of measures that can be taken. Things like building seawalls, like restoring wetlands to their protective state, things of that kind. So that should be part of development efforts, really.
Stephen, thank you very much for your time.
That's a pleasure.
You can find links to Stephen Castle's work and to the report that he mentioned on our website at scienceforthepeople.ca. While you're there, check out the site and click the links to Twitter, Facebook, Google+, and iTunes, where you can subscribe to the show, listen to past episodes, or leave a review. Thanks for listening, and we'll see you next week on Science for the People. Science for the People is recorded in Edmonton, Alberta. The show is produced by Rochelle Saunders. Ryan Bromsgrove is our promotions manager. Our social media manager is Chelsea Butler. K.O. Myers updates our website. Helen Quivalon is our publishing liaison. Ed Haynes is our guest coordinator. We get research help from Josh Whitten. The show is edited by K.O. Myers and Ryan Bromsgrove. Our theme song was written and recorded by Fractal Pattern and its title is Binary Consequence. The show is hosted by Rochelle Saunders, Marie Claire Shanahan, and me, Desiree Schell.